Hello everyone, welcome to lecture 10. And in this lecture, I will talk about unsupervised machine learning. And I also talk about K-means algorithm. And I think one of the problem in assignment 5 is about the K-means. So as a reminder, the deadline for the assignment 5 is next Tuesday, and you need to submit your code in Gradescope and also a PDF for your project for the assignment 5 in the Gradescope as well. So let's see some reviews about the machine learning that we talk in the previous lecture. So as we show that the machine learning is a collection of algorithms that detect and exploit patterns in the data, right? So we can assume different goals for the machine learning. And for example, one of important goals that we have for machine learning is predicting labels or outcome based on future data points. For example, classification can be considered as a application for this goal, because getting some data point, we need to predict the label for the data point. And another goal for the machine learning can be generating data that is so similar to real data. And so in this goal, we have a system that get the real data and generate fake data that are so close to each other. And another one is controlling an agent in an environment to achieve a goal. For example, in your reinforcement learning, you have an agent that get the current state of the environment and try to achieve a goal based on predicting some action. And as a last goal, we need to explain patterns in data with direct interpretation of model parameter. For example, we can consider K-means algorithm from this category, and in this lecture I will talk about that, and I will explain the K-means algorithm. So we also saw some paradigms for the machine learning problems, and we talk about the classification that we get data points, and we want to predict the label for each data point. And regression also is so close to classification, but instead of predicting the label for each data point, we need to predict the real value. And for reinforcement learning, as I mentioned in the previous slides, we have an agent and we want to map the current state to action. Actually, we want to predict an action in each step for the agent to achieve a goal. So for generating modeling, we want to generate some data instead of predicting labels. And for the clustering, we have data point and we need to group the similar data point together. And actually we can consider the classification, regression, and reinforcement learning as a supervised approach, and the generative modeling and clustering as an unsupervised approach. So what are unsupervised and supervised approaches? So in supervised approaches, we have input and output pairs, which means that we have some features for each data point, and also we know the label for each data point. And the goal is to predict label for new input points. For example, we want to predict the probability distribution over all labels given X. And then, for example, we have two labels and we want to compute a probability for each label given X. Then we can detect, we can get the maximum probability as a label. And in unsupervised approach, actually we have just data points without label. So we don't have a label in the unsupervised approaches, and the goal is to learn a probability of each data point. And also sometimes we can consider actually we can invent labels. So for unsupervised approaches, then based on the probability of the invented labels, we can explain the data. And you need to know that, especially for doing assignment 5, you need to know that we can use both supervised and unsupervised learning on the same data set, but we need to ignore the labels for the unsupervised learning, right? Because, for example, for assignment 5, we are using iris dataset, and in iris dataset we have features and labels. So for supervised learning, we can use the labels in the training. And for unsupervised learning, we just need to ignore the labels and then use just features. And in this way, we can use the same data set for supervised and unsupervised. So if we want to see an example of this, for example, here, I just load iris data set, and I want to use same data for supervised and unsupervised. So how can I do that? So for the supervised, we get the all data, which is all features, actually all columns that are each column is a feature in the data set, and also the last column, which is actually the last column is a label. So if we get all data as a supervised data set, which means that we are using this data for this unsupervised learning. So if we want to use the same data set for unsupervised data, we just need to ignore the last column, which is the label for each data point, by using this indexing, right? And so this means that we are getting the all columns and ignoring the last column, which is the label for the unsupervised data. And actually, now I want to talk about the clustering, which is an unsupervised algorithm. And in clustering, you define a set of cluster, C1, C2 up to CK, and you want to assign each data point in your data set to some cluster, right? So some use cases for clustering is that feature importance. For this one, consider that we have one feature that are so close that have actually each cluster have very close values for one features, and this means that this feature is so important because we can use these features. We can use this feature to find the difference between two cluster or three cluster, right? So this means that one feature is so important if cluster have very close values for that feature. Another one is anomaly detection. So actually, in most of the data set, all data point that we have should actually make a few large clusters, right? So this means that most of the data point that we have in the data set can be similar to each other, and this can help us to make a few large cluster. But if we have some data points that are not similar to other data points, we can consider them as outliers, right? Because they are not similar to other data points. This also can help to find or detect anomaly in the dataset. And another one is the product recommendation. This means that we want to identify groups by clustering product or customers. So for example, we have some user and we need to cluster them to find similar user. Then if we are recommending a product to a user, this means that we can also recommend that item to other user in the same cluster because these users are similar and we consider them as a one cluster. So if we can recommend the product to one of them and get a positive reward, or the user purchase that product, this means that there is a good chance that other user in that cluster like this product. So in this case, we can recommend the items to other user in the same cluster. So for the clustering, I show an example here that we have some data point with two features, x1 and x2. And as you can see, we can cluster them. Actually, we can group them into three clusters, and C1, C2, and C3. So in this case, for example, you can consider this one as one group of user, and this one and this cluster as another group. And now we want to know that how we can say that, okay, this data point should be a member of this cluster or this cluster. So KMeans an algorithm to do that. And actually the K-mean is a unsupervised and parametric approach. And at the first, we need to fix number of cluster K, and this means that each data point that we have in the data set need to be exactly one member of one of these clusters. And also we have a representation for each cluster, which means that for each cluster we have we can represent each cluster by cluster center. And the cluster center can be imagined point, which means that the cluster can be, the center of cluster can be a point which is not actually represented in data set. And if we want to assign each data point, we need to assign each data point to nearest cluster center. So for the K-means clustering, we are using Lloyd's algorithm, and actually Lloyd's algorithm can find this cluster that we show here. So let's see the step for this algorithm, then I will show some example for this one, and then I think after that would be clear to you how this algorithm works. And at the first, suppose that we are working on a data set with d-dimensional, which means that each data point has a d feature, has a d numbers. Actually, the dimension of each data point is d, right? So at the first step, this algorithm randomly initialize the center of each cluster, and for example, if we have k cluster, we just need to randomly select k points actually in the data set to as a center of each cluster, and then we assign each data point to the closest cluster center, right? So we just need to find the distance between each data point and k points that we initialize at the first step. In the third step, for each cluster center, we need to update the center of cluster based on data point that we assigned in the second step. So this means that in the third step, we are changing the center of cluster based on the data point that we have for each cluster. And finally, in the last step, we just need to repeat step 2 and step 3 until we converge, or after a fixed number of iteration. So these are steps for Lloyd's algorithm to find the clusters in the data step. So if we want to show the algorithm in an example, if we have a data set like this with two features, x1 and x2 for each data point, which d is equal to 2 in this example, actually. And then for in the first step, we need to select 3 center randomly. For example, here we have 3 center because we consider k as equal to 3. We want to find 3 clusters in this data set. So we at the first we consider 3 randomly position in the data set. So also note that these are imagined data points. We don't have actually data point in this position, right? We just need to select them randomly. After that, we need to find the distance between each data point to each this center. For example, this one is close to a blue one, right? So we can consider this as a member of the blue cluster. Or this one is close to red one, and then all these points are close to the green one. So after that, you can see each data point is a member of one of these cluster, right? So after that, after assigning a cluster for each data point, we can update the center of cluster. So in the third, for each cluster center, we update its location to be the mean of the point assigned to it. So this means that after assigning the points to each cluster, we need to update the center of cluster by averaging the data point that we have in that cluster. So after that, we change the center, and now we repeat the previous step. Means that we find the distance of each data point to new center of each cluster to decide that, okay, the previous cluster was true or not. So after that, for example, this one is close to center of red cluster, and we should change the color of this data point to red instead of blue, right? So we can do that for all data points that we have here in the figure. So after that, you can see the cluster rate getting more members, and then we can do that until after that we can update the center of cluster again, and then we can do that for a fixed number of iteration or wait until the algorithm converge, right? So that would be iteration 2, iteration 3, and this means that after iteration 3, we converge to this cluster. So actually, this algorithm is fairly intuitive, and the, the 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 cluster that we find by this algorithm are meaningful, and actually they are so good. But we should know that the K-means is minimizing the specific object function. What is this objective function that we are minimizing in the K-means? Consider that the optimal cluster center, we have C star 1 up to C star K, as an optimal cluster center. So the K-means actually minimize the sum of square distance from each data point to its closest cluster center, which means that we have some data point and we can have different center cluster, but we want those center cluster that minimize this evaluation object here, right? So we can consider them as an optimal cluster center if they minimize this quantity. So you should know that actually the Lloyd's algorithm only converge to a local minimum, which means that this algorithm cannot find the best solution for center of cluster. So, and also even worse, if you have different initial value, initial center, different initial center, and the algorithm can converge to different centers for clusters, and that cannot be good because you want to find exact same solution for each data point for each data set that you have. But if you change this initial center of cluster, which we select them randomly, if you change this algorithm can converge to another solution. And also other algorithm proposed by other people that they can be close to the optimal value, but actually in the practice, most of the people use the Lloyd's algorithm because this algorithm is so fast and simple, and actually the solution that can be found by this algorithm is not too bad. And this is a trade-off between time for the algorithm and the actually the performance of the algorithm. But I think most of the people prefer to use the algorithm because this is so simple and fast, and in most cases near the optimal values. So actually, K-means algorithm is implemented in scikit-learn. You don't want to actually implement that, and you can use the scikit-learn to find the cluster in your data. So I have an example here to show how we can use K-means clustering in scikit-learn. So we have three data set, actually the three cluster. We are making them randomly by np.random.rand, which is returning random numbers from normal distribution, and with different mean, because for the first one, x1, the mean is 0, and we are changing the mean for the second one, which is 2, and then for the third one, which is -2. Actually, we are making cluster by ourselves, and then we concatenate them, and then I import K-means from scikit-learn clustering, And then I use the KMeans constructor to make a model by KMeans from scikit-learn and pass an argument, which is the number of cluster that we want in the output, which is 3 here. And the K-means modeling that I just created has a function which is the name of the function is fit, and then getting the data point that you have in the data set. This means that we are applying the K-means on our data set, which is X, right? And after that, we have another function, which is labels, and we can get the labels of each data point to see the index of the cluster for each data point. For example, here we have we have the 15 data point for the one-off cluster, then we have 10 data point for another cluster, and 20 data point for the another cluster. So we ask after applying X, after applying K-means on X, we ask about the cluster that we assign to data point with index 10. So we already know that the data point index 10 is from this data set, from this actually cluster. And we ask about 20 and 30. So the index that K-means return for the first one is 2, and then the second one is after 15 we have 25 number of points here, which means that index 20 is from another cluster, right? So we can see that the label for this index is different than the first one. And also, if we want to know that what is the cluster of index 30, so we have 25 data points until here, and then we have 45 by using this data point. So this means that the 30 index is from another dataset, which means that these should be different than the other two cluster, which actually is good because the K-means can cluster these data that we generated by np.random.random, right? So for the evaluation, we need to know that the performance of the algorithm of unsupervised model like K-means, right? So if we have labeled test set, then we can compute the accuracy or measure that, right, based on the labels. But in unsupervised model, we don't have labels, so we can just compute the objective function, which is for example, in the K-means, is the sum of square distance to center. And then we can measure this objective function on a test set or even on the training set, and then evaluate the model. We can do that on the training set because we don't have any label for the training set, and then it actually makes sense to do that on the training set. But in the classification, it doesn't make sense because we already saw that the labels on the training, and we need to have a different set to evaluate the model. Also, how there is a question that how we can select the best value for the K, which is the number of cluster. So we can do that by different approach. The first one is that we need to fit the models for multiple value of K, and then measure their objective value on the validation set, which the objective function is there, for example, for the KMeans is a sum of square distance to the center. And for the, as I mentioned, in the unsupervised algorithm, we just need to simply measure the objective value directly on the training data instead, which means that in unsupervised learning or in unsupervised algorithm, we don't need actually the validation set or set, a test set. We can do that on the training data. And that's the reason is that we don't have any labels in the training data. So we shouldn't worry about using training as an evaluation data set. So this is the whole that I want to in this lecture, because we have a problem in assignment 5 about the K-means clustering, but actually you don't want to implement that. You just need to using scikit-learn library to use K-means and then making cluster on the dataset. So if you have any question about each problem in assignment 5 or about this algorithm that we cover in the lecture 9 and 10, you can ask by sending a post on Piazza or sending an email. That's it. Thanks and see you later. Bye.